Okay, so today we're going to be looking at advanced reading and writing. I'll chat this out to everybody so that you know where we are in the manual. Today we're going to look at advanced reading and writing. We're going to start with zip files. After that, we're going to look at fanouts, generic reading, writing, and dynamic translations. These features add a lot of flexibility to your workspaces. Now, I have a tendency just to call them zip files. More accurately, we're looking at how FME handles archive files. There are actually quite a few different formats of archive files. So FME supports a number of different archive formats. Archive files are a way to read and write output data as a single unit. We touch very briefly on zip file handling during the basic training course, where reading from a zip file was covered. FME can read both zipped file-based and folder-based data sets. You can add a zip file as your source data set for any reader. The important thing to remember, though, is that the file browser doesn't automatically display zip files. If you've selected that you want to read from MapInfo tab files and go to look for a zip file, by default, it won't be showing you the zip files. You'll have to change the filter. So you can see that here. So if you're looking for a zip file and you don't see it, that's probably why. Here you can see some of the various archive formats. 7-zip is a very popular one. RAR is also quite common out there as well. FME can also write to zip files as well. Basically, it treats the zip file in the path here almost like a subfolder. And then you can have subfolders within that zip file or files within that zip file. So you can click on this zip button, or if you're just typing in .zip, it'll automatically assume that it's a zip file. And the output is a zip file. Just a show of hands, how many of you work on a Citrix-based system? Nobody. Okay, never mind then. Web-based datasets. With the increase of data stored on the web in the cloud, it is useful to note that FME can read web-based data as well. The simplest way to do that is just simple URL selection. We can't browse for a web data set using the options here, but if you simply take the path and enter it here, that'll work just fine. As an example, quite often there are open data catalogs which are available. So you can see we have a variety of different data sets here. So let's see, we have an bikeways as a shapefile. If I copy this path, and you can see down at the bottom there, it was open data shape bikeways underscore shape dot zip. In Workbench here, I'll drop in a creator, a feature, just reader. And in my feature, the format will be ESRI shapefile. And I just type in the path. When I hit OK, it'll read in that data set. And there's my data set there. So I can then read that. When reading web-based data sets, it's a good idea to have feature caching turned on because they do read a little bit slower. They're not being read from your local disk. So being able to cache them up is really handy. So there's the Vancouver bikeways from their open data catalog. Here's an example of reading a MapInfo tab dataset. Again, it has to be zipped up. Shape files and tab files actually consist of multiple files. In that situation, all the files have to be within a zip file. If I was reading in the DWG file here, let me just hover over this, see what it actually gives me for the link. The DWG file is also zipped, but if it was just a straight DWG file, I could read that in because it's reading in a single file. So the web-based data sets, it has to be a single file, which means that the format is either a single file or you've taken multiple files and zipped them up. Now, sometimes having the URL is not enough. You have to be able to sign in to the web provider, I guess. To read from the various cloud or web providers out there, you need to create a web connection. So you can set up a web connection by going through the Tools, FME Options, Web Connections. So Tools, FME Options, and then down here we have the Web Connections. So notice we have the database connections, web connections. We actually saw we saw the database connection yesterday when we were connecting to our PostGIS database for the final exercise. The web connections work exactly the same way. This is just a way of storing your connection credentials on your own machine, separate from your workspace. So if I hand someone else the workspace, I am not handing them my credentials. There's a number of different web services that you can create your credentials for. So you can see them here. And then in the reader itself, when you select the down arrow here, we can select file from web, and then you can connect to one of those web connections. So for example, if I want to connect to an Amazon S3, I would create an Amazon AWS web connector. And then it has some authentication, region, there's usually a private key, something secret, I can't remember exactly how they term it. You have to enter all that in, perhaps which bucket you want to read from, and then you can read in those files. So that's if you want to do it directly from a reader. For myself, I've found that whenever I have to interact with one of those web data sets, it's very rarely at the very beginning. Usually I have some other tasks to figure out what it is I'm going to be reading first. So usually the connector transformers end up being more useful. So for each of those connections, we do have a transformer specifically to deal with it, because sometimes you're looking to read, sometimes you're looking to write, sometimes you just want a list of what's there. So something like the S3 connector transformer, it can perform all of those actions. You'll notice that this S3 connector transformer, I didn't show it very quickly there. It had a different little icon, a little cube. That means it's part of the FME hub. A lot of these transformers now we're keeping on the hub because they will have to be updated on a regular basis. Because these are using services external to our own, whenever those services are updated, we have to be able to quickly update all the transformers as well in order for them to continue working. If we were simply releasing these transformers every time we released FME, that would mean that when one of these web services updates their libraries, then all of these transformers would stop working until we came up with a new version of FME. So having them available on the hub is important. In this S3 connector here, we can see that there's a number of actions. So there's a number of things that you can do. We can delete, download, list, upload. You could break those down into things which you could do with a reader, but quite often you'll want to list everything that's there, sort through that list, find what you actually want, and then upload or download your data. I've had a workspace where I had to list everything, download what I wanted, delete everything else, and then re-upload what I've recreated. Just using readers and writers wouldn't work for that. Okay, so let's move on to exercise 1. In this exercise, we have two data sets. We have a roads data set, an AutoCAD DWG file. We have a Microsoft Excel file containing snowfall. We want to join the snowfall data to the roads and upload this to an FME server resource folder. Don't worry about this. I'll talk you through it when we get there. So we're joining snowfall data to a set of road features. Just going to move my manual over. I'll paste out the link to this exercise. And then we're going to start with a blank workspace. Okay, so we have our blank workspace. Let's add in a reader, DWG. So we'll choose the AutoCAD DWG DXF reader. So remember, you can always add readers and writers using the quick add. That's typically how I do it. You can just type in a bit of the format and select it from the readers. That'll bring up this dialog. It auto-fills in the format. Now we just need to find the data set. The data set is C FME Data, Data, Transportation, Complete Roads.dwg. Okay, so FME Data, 2019 data. Transportation, Complete Roads. There we go. Now, this data has extended entity data. For those of you who never work with DWG files, you don't need to know this. For those of you who work with DWG files on a regular basis and extended entity data sounds familiar to you, here's something really important, and we all need to do this right now. We need to go into the properties and make sure we group by attribute schema. Otherwise, the extended entity data will not be read in. Often a good idea to save that as your defaults. So when you open this up, if you don't have any attributes, then you will have to add the reader again. Coordinate system, Generally speaking, CAD formats are not coordinate system aware. But let's leave this as unknown for now and inspect the data and just see what we get. Group entities by attributes, single merged feature type. So we're going to do not individual feature types, we want a single merged one because really we just want to deal with all the data. So we'll use a single merged feature type. And OK. There we go. And we have a bunch of attributes. Let's run just this. And let's inspect what we cache up. Okay, so it is data that looks like this. One of the things that you'll notice here is that it says it has a coordinate system, UTM 83-10. See if I can turn on a background map as well. Let's see if it reprojects into somewhere in the real world. And it does. So we've been telling you that DWG files, CAD files, typically are not coordinate system aware, but this one seems to be. The reason for that is that we're stealing a trick from ESRI. There's a PRJ file there. These are the same sort of PRJ files you find with ESRI shape files. There's websites out there as well that will generate you a PRJ file based on a coordinate system that you specify. If you have a PRJ file with the same name as the file for many different formats in FME, FME will use that PRJ file and make it coordinate system aware. Sort of give away that this is an ESRI hack. If I rename this to ESRI_CAD, that PRJ file will then apply to all of the files within this folder, or at least all the files that FME will use the PRJ file trick with. I've often been disappointed that it doesn't seem to work with the Rhodes DGN file. But there we are. So I've used the ESRI CAD PRJ instead, and it still picks up the coordinate system. Okay, so now we've got our CAD file in there. We should save our workspace. We'll save this into the workspaces folder. And we will call this exercise. And today is day 3, exercise 1, 3.1. Now for the snowfall dataset, we've put a bunch of data into an S3 bucket called FME Data. If I click on that link there, or let me paste this out to everyone as well. If I click on that, there we are. Nice little web page, has some data. So the Excel spreadsheet, if you look down at the bar down at the bottom here, you can see that that is just a straight Excel spreadsheet. The map info tab file, because it's multiple files, is a zip file. Google KML is just a KML file. And then we also have the Excel spreadsheet zipped up. So we want this path here. I'm going to copy that link address. Again, I'll paste it out to everyone as well. Now we're not going to read it in. I mean, that is an option, but we're not going to read it in. Instead, we're going to query it using a database joiner transformer. So let's connect up the database joiner transformer. FME can treat Excel spreadsheets like a database. So the format, Excel, Dataset. Oops, I can't navigate for the dataset. I just have to enter in the path. Let's see the parameters here. So it's just quickly downloaded that. And this is what it looks like inside that file. That all looks reasonably good. So it's going to read in that Excel spreadsheet. The table I want to join on is the snowfall table. And I can match things by the street ID. So I've got the street ID. This is on my AutoCAD file. If you don't have a street ID on your AutoCAD file, it's because you did not group by attribute schema. So the extended entity data is not being read. The only way to get around that is to delete that reader, add it again, and make sure you set the parameter to group by attribute schema. Next up, for our table field, doesn't look like it knows. Oh wait, I can select a table field. So that queries the database, whichever you may have, in this case, Excel spreadsheet, and I can choose my street ID. Now I'm seeing some questions come in that you can't paste the link to the VM. So if you're outside the machine and you try to paste it in, sometimes that's a limitation of remote desktop. There should be a parameter somewhere in remote desktop, a setting that would allow you to share clipboards, but that might take a bit of time to find. At the moment, as painful as it is, you may have to type in the paths directly. Just be aware this is HTTPS, and these URLs tend to be case sensitive. FME data with capitals here as a bucket would be quite different from lowercase. And there's a capital I as well, capital S. So watch out for those capital letters. Okay, fields to add. We can select which attributes it will retrieve from the database. Sometimes you want all of them. In this case, we're only looking for a handful of them: estimated snowfall, last treated, temperature, and weather station. So with fields to add, let's click on the three-dot button, and we want the estimated snowfall, last treated, temperature, and weather station. We want to match to 1, 0, or many. So cardinality is match first, 1 to 0, or 1, or more than 1. and then we hit OK. Now let's see what that gives us. So I now have these features here. When I inspect them, I don't care about the geometry at the moment. I care about the attributes. And I can see that for these roads, I now have an estimated snowfall, last treated, temperature, and weather station. Now, while other people are catching up, a quick note on the database joiner and performance. If we are trying to retrieve features, a relatively small number of features from a vast database, the database joiner is an excellent way to do that. But keep in mind that as each query comes in, it's sending the query out to the database and then getting it back. In this case, the database joiner, because it's reading an Excel spreadsheet, it's actually reading in that entire Excel spreadsheet, caching it locally, and then just querying against it. So ultimately, this is not giving us any better performance than just reading in that Excel spreadsheet and then setting it through a feature joiner transformer. So the database joiner gives you your best performance and is most useful when reading from a live database like SQL, SQL Server, PostgreSQL, Oracle, things like that, where the number of queries are relatively low and the database volume is very high. Now we want things to look pretty, so let's add a KML styler. So we'll attach a KML styler to our database joiner. We'll go into the properties of that, KML styler, yes. The colors. Let's see, they gave it 3 possible values according to the amount of expected snowfall. Do we actually indicate what that would be? I don't even know. Let's just set it all as blue. And the line width. Yeah, I'll leave that at 1. So we won't bother with the conditionals. Now we want to add a feature writer transformer. Now the reason why we're using a feature writer instead of just a writer is that once we've written this out, there's additional actions we're going to want to take. And if there's additional actions you want to do after writing out, the only real way to do that is by using the feature writer. I mean, there is also an option of using under Workspace parameters, scripting, there's a shutdown Python script. That is a possibility, but pretty much anything you're going to do here, you could do by using a feature writer and then going through the script. And doing that here in the canvas instead of here in this dialog is a whole lot easier to troubleshoot. It also makes it far more apparent that that is happening when someone else inherits your workspace and has to troubleshoot it. So we drop in a feature writer. Just got to resize. Oh, no, that's not what I wanted to do. Resize this. That's as small as it'll get. Okay. So we're going to write out to Google KML. The data set is going to be /FME Data 2019 /output /training /road snowfall.kml. And then we can save that. Actually, let's zip that output. So now it's calling it roadfall.zip, roadfall.kml. And the name of this output, the feature type name, KML styled, not the greatest feature type name. Let's call this snowfall predictions. Now, in all honesty, if you wanted a zip KML file, you would just change this name from KML to KMZ. But for other purposes, we're going to go with a road snowfall.zip file instead. Now let's run to that point, actually create that file. If I open up that folder, I see that I have my output training. There's my roadfall.zip file. If I open that up, I can find my roadfall KML file. Now the feature writer, when it finishes writing, it outputs one summary port feature. We can see the dataset name. That's the name of the file it wrote out. Notice it's the entire name, including the snowfall.kml, and it tells you how many features it wrote out as well. So now we can make use of this with one of our connectors. I can upload it to a web service. So let's click on the output port of our feature writer. And we're going to run this through to a FME Server Resource Connector. FME Server Resource Connector Transformer. The FME Server Resource Connector Transformer can be used to manipulate the resource folder in an FME server installation. Basically use it as a cloud drive. So let's open up the properties to this. So this is our FME Server Resource Connector. We are going to upload a file. The options are delete, download, list, or upload. just like the S3 connector. We're going to upload. Now we need to select our FME server account. So let's click down and let's add a web connection. So we'll add a web connection. We can call this my FME server. So we'll call it my FME server. The URL is HTTP localhost. All of your training machines have FME server installed on them. With a bit of luck, they're actually up and running too. We'll find out in a moment. Username, author. Password, author. And then we'll hit authenticate. If anyone didn't have that work when you hit authenticate, let me know and we can try something a little fancy. So if it didn't authenticate, let us know right now through the questions panel. Okay, questions panel looks quiet. I'm assuming it worked for everyone. So we have connected to an FME server installation. Now we need to select which file, and you can upload a file, a folder, or an attribute, which file we want to upload. We don't have a whole lot of attributes to pass into this, so obviously it's going to be Dataset. Now I'm seeing messages coming in. What's the fancy thing? This should work for people. Let me just double check here. My IP address lookup. This is my IP address. What you should be able to do, and I'm hoping this will work, for your web connection, I'm just going to cancel out of this. You can try this. So server account, I'm going to add a web connection. The web connection is going to be my IP address. The server URL will be my IP address. Username, author, password, author, and then try authenticate. Cross your fingies. So far, that's not looking too helpful. Argentine. Looks like I didn't open up a sufficient port on the VM. So unfortunately, that's not going to work for us today. I'll see if I can quickly fix that over the break, but it looks like the fancy idea isn't going to do it, which was just to have everyone use my own. Okay, so I'll have to reconfigure this here, upload. So unfortunately, for those of you that aren't able to connect at the moment, you're just going to have to observe this part. And then if we manage to have time to troubleshoot it, we'll see what we can do later on. So for the rest of you, the rest of this is just observing. So we're going to upload not our zip file, sorry. We're going to grab it from a value of Dataset. That'll be the name of the file. The folder ID. This is again linking into FME server. And we have our data, and we'll just upload it to our data folder. We hit OK for step number 7, and then run the translation. We can just run this bit right here because the file's been created. Now we'll just publish that up to FME server. And things go off the rails. Let's take a look at the error message. Error encountered while calling method input, FME server caller, Python failed to process feature, a fatal error has occurred, the log file above for more detail. If I unfocus that. So this bit right here made it pretty darn unhappy. Python exception, trace back. Here, okay, file not found. No such file or directory. It was trying to upload FME Data 2019 output training roadsnowfall.zip, roadsnowfall.kml. Now you may be thinking, I'm pretty sure that file exists. We navigated right to it right here. I mean, there it is. FME Data 2019 output training snowfall.zip, snowfall. But we're only seeing it as snowfall.zip because the file browser here is kind enough to let us navigate into zip files. Most systems don't actually allow you to do that. So when it's looking for a roadsnowfall.zip folder, it's not finding that. It's just finding a file named that. And then beyond that, it's not going to look inside that zip file. It's never going to find that KML file. So as far as this transform is concerned, this file itself does not exist. But this file right here does. So what we need to do is cut off the end of this path. So that's what we're going to do. Between our feature writer and our FME server resource connector, we're going to drop in a string replacer. I found that whenever I'm working with online services, I end up using a string replacer quite often because quite often the paths that we end up creating in FME aren't quite right. This one seems to be okay, having doubled up slashes. I've found that some services work perfectly fine with doubled up slashes. If there's double slashes, it just assumes that you have it right. Other systems, not so much. So in our string replacer, we are going to replace our data set, or we're going to update our data set. We're not going to replace text, we're going to replace a regular expression. If we're replacing the text, I'd have to replace the road snowfall. But what if later on I want to use a different file name? I want this to be, I want this to scale better, more flexible. It is not case sensitive. The regular expression to use, I'm just going to copy paste this out to everyone so you can see it, is that. So 2 slashes, square bracket, caret, 2 slashes, end bracket, star, $sign. I know that doesn't make a whole lot of sense. It's starting from the back, so it's matching the end. I can't remember what the star means. The bracket is what characters, and we're looking for a slash. Actually, I believe that this is a escape and then a slash. So that's why it looks weird. Building regular expressions is often tricky. So we hit OK. Because building regular expressions is often tricky, I noticed that we didn't set a replacement text. That's because we're replacing it with nothing. Because regular expressions are often tricky, it's always a good idea to inspect what it is you're getting. Make sure this actually worked. There we are. So it grabbed that last slash, got rid of everything. So what would happen if we don't have those extra slashes in there? And I run to that. Let's see, does that still work? Nope. So you definitely need those extra slashes. Okay, so now I have a correct value for data for the correct data set for our snowfall. And I'm going to tell the FME server to upload that particular file. That should work just fine now. So let's run this out to the FME server connector. And now we don't end up with any terrible log file messages. We have a bunch of warnings, but it's all our usual warnings. And we have one output feature. The output feature gives us our data set, total features written. That's from the writer earlier, the path to it. But the FME Server Resource Connector also added 2 more links, or 2 more attributes, our shareable link and our direct download link. Let's see what those give us. So here's our shareable link. I can grab all of that, Control C. Let's see what that gives us in a browser. Gives us information, metadata about that particular file. And the other link is the direct download link. Let's see what that gives us. There we are. We just downloaded that zip file. And there's our roadsnowfall.kml file. So we've uploaded that to a cloud drive. Fanouts is quite useful functionality, which can create great results with very little effort. Fanout is a way of splitting up your data into multiple outputs. This is accomplished by setting the output feature type name or data set to an attribute value or a concatenated combination of attribute and fixed strings. In the image here, we have features being fanned out or split up based on the value of the elevation attribute. So we have separate outputs for each specific value of elevation. Now we can fan out the data like this at either the feature type level or the data set level. Actually, it's not really an either. We can fan out them by the feature type and the data set. Let's take a look at feature type fanouts first. A feature type fanout means we are creating separate layers in an output according to a value. Feature type fanouts are set on the destination feature type. So on the destination feature type here, we have the sheet name. Usually you give that a specific value, but you do have the option of choosing an attribute that will supply the value. You can even get more complicated by using the text editor. Then you can use a combination of attributes and constants. So for example, here we fan out on neighborhood name, so we'd end up with a separate feature type for each value of neighborhood name. You can also fan out on the data set. For example, here, fan out by elevation, and we end up with separate DXF files. If I was fanning out the data set of a shapefile, I'd end up with different folders. Setting a dataset fanout is done in the Navigator panel. In the parameters for a writer, you'll find a fanout dataset. By default, this is set to no. When you turn it on, you'll be given this dialog. You can then choose the output or fanout directory and the fanout dataset with a fanout expression. So we fan out the dataset, you turn that on, then you can give it the expression. And again, there's a text editor, and you can make that as complex as you want, or you can just choose the attribute value. So pop quiz. Fanouts are an important part of writing data with FME. Which of these statements are true? You can have both a feature type fanout and a dataset fanout in the same workspace. I mentioned at the top of the page, yes, you can. You can use a feature type fanout with a database format, but not a dataset fanout. You can definitely use a feature type fanout with a database format. For the dataset fanout, you might be able to, but it's probably not going to make a whole lot of sense. You'd be writing out to different databases. So I'm going to say no, you can't, but it wouldn't surprise me at all if you could. A fanout expression can be an attribute or a constructed string, but not a user parameter. I don't think that's true, because ultimately you can take a user parameter and make it an attribute using the parameter fetcher. So I'm going to say that's not true. And a fanout cannot be based on a format attribute such as FME color. Well, FME color is really just another attribute. You may have to expose it as an attribute, but I'm going to say that you can. So let's check. Okay. So I got that one right, Let's show the correct answers. Okay, so I got all of it right. Woohoo! I get to keep my FME professional designation. Okay, the generic reader. Most readers and writers in FME can only read or write a single format. However, sometimes you want just a little bit more flexibility. And this is where the generic reader and generic writer can help. Now, generally speaking, if you're running FME from the desktop, probably not going to be doing this. For your own purposes, you have fine control over Workbench. It would be easy enough for you to set up multiple readers, multiple writers to handle what you want. But where this often comes in handy is if you are then going to be publishing your workspace to FME server. Once a workspace is on FME server, then anyone with access to that can then run the translation. And they may be handing in data or submitting data from multiple data formats. They may be expecting results in multiple data formats, and then it can become a little bit easier to manage if you use a generic reader or a generic writer. The generic reader can detect the format of the source data set from the file extension. Of course, it only works with file or folder-based formats. It is, of course, possible to set the format directly, but it can be changed by a user later. Assuming that the schema is the same, the translation will still work. So if people are submitting design files, but they could also be submitting DWG files, you could use a generic reader to support both of those formats. Because you're giving the user control over choosing the format, you'll notice that the generic readers do not have many parameters. If I look at a generic reader here, there's not a lot of parameters to set. If there are particular parameters that you want to set, you can add a reader as a resource. And if that format is selected, its parameters will be used. The resources is probably something you've noticed in the navigator, but may have been uncertain about what it's for. I have our Workspace resources right here. This is a way that I can add a reader without actually adding any feature types or having it affect the performance. So it doesn't show up as a reader up here, shows up as a reader down here. What we are reading in is not important. It'll never read this file in again. What is important is what I'm setting here as my parameters. So I can add this as a resource, hit OK, and then a generic reader, whenever I want to read in an AutoCAD file, it will then use the parameters from that reader. So now I have my resource, and there's my AutoCAD reader, which is really just storing the parameter settings. If you're using different formats, chances are the feature type names will also be changing. So it's a good idea to turn on a merge filter to handle this. So within the source feature type, you can double click on that, turn on merge feature type. It'll generally merge on a wildcard of everything. That'll be called all out here. That way, everything that comes in will come in through this feature type. So now we can handle multiple formats with multiple feature types. The generic writer works basically like a generic reader. At some time before the translation is run, the output format will be specified. You can publish this parameter so users are asked to choose their desired format. You can also add a writer without feature types if you want to set parameters, similar to adding a reader as a resource. So there's no writer resources in the interface here. These workspace resources here, these are for readers. But for writers, we would simply add a writer, but not actually specify any feature types. Remember when we were doing the performance analysis yesterday, if a feature does not arrive at a feature type for a writer, that writer is not, I guess, instantiated would be the word. So there's no performance hit to having writers with no feature types in them. But the generic writer, if it's using the same writer format, will make use of those writer parameters. So we can set the output format directly. We can publish this as a parameter and allow end users to select it. And then they can choose their output format. Now, if this all sounds like it would be tricky to debug, it is. For the most part, you only use this if you absolutely have to. It just gives you a lot more flexibility when you're working with FME Server, in my own experience. So let's take a look at this as an exercise 2. Our source data set will be a file geodatabase. Just imagine that this is just a big geodatabase. Generally speaking, if you're doing community mapping, you're probably keeping all of that in a database somewhere. But you want to allow end users to grab data sets or feature classes of their choice and download it as the format of their choice. So we can do that by using a generic writer, Fanouts, and writing out zip files. So let's begin. We'll save our previous workspace and create a new one. We'll create a blank workspace. We'll then add a reader. We want the file GeoDB Open API reader on the canvas. If you just type in Open API, that'll suggest the ESRI GeoDatabase Open API reader. The dataset is FME Data 2019 Data Community Mapping Community Map.gdb. So let's go find that. / FME Data. Oh, it doesn't automatically suggest it. Okay, FME Data 2019 Data Community Mapping Community Map.gdb. For those of you that work with a file geodatabase on a regular basis, just keep in mind that with this interface here, you can drag items over, and then they become a shortcut to that file or folder. Parameters. With a normal database, if you don't choose any tables, nothing will be read in. But file-based databases are a little bit different. They work the opposite way. If you don't specify a table, everything will be read in. So let's just hit OK, and we'll bring this all in as a single merged feature type. So everything will come in through that feature type, and we'll hit OK. Boy, that's a lot of attributes. That's attributes from every single feature type. Bit of foreshadowing, that might cause some trouble, but there's ways around that. Okay, we've added our reader. Let's save our workspace. We'll save this as exercise 3.2. Now we want a writer. So on the canvas, we'll just type in generic. We have our generic reader, and we have our generic writer. Let's select the generic writer. So we have the format, the data set. It'll ask you for output folders generally. So if I click on that, I can just choose our FME Data 2019 output training. That should suffice. So there's our output folder. Let's check the parameters there. Output format. We could leave this blank and we'll be prompted for it later on, but let's cut to the chase and do a shapefile. Base file name, MIME types. You see there's a number of things here that you can set. Okay, feature type definition, copy from reader. Sure, why not? Called it food vendors. That's probably not what this is ultimately going to be. Looks like it just grabbed the first from the list. So let's clean up this feature type. Whenever you add a transform or a feature type, it's always important to go into it and review all the possible settings. Feature type name. We'll probably come back to this. Food vendors would be a little misleading. Let's just call this new feature type for now, or something along those lines. The writer, generic. The geometry. Now we're writing out to ESRI shapefile. ESRI shapefiles are very strict about their geometries. You're allowed one geometry per shapefile. If we set this to point, then anything which is not a point will never get written out to the shapefile. There are some other options in the drop down here. There's FME any. That's probably a good spot to start. So we're telling it to use any, and then we're going to rely on the writer itself to go, okay, this shapefile here, a point just came in. This is going to be a point shapefile. We hit OK. So we have all of this going into all of this. I'll give everyone a moment to catch up. Now, for something like this, the prompt and run, or prompt for user parameters, that's going to be important. So we want to make sure that's on, prompting for user parameters. The parameters that are going to be prompted for are everything in the navigator down here under publish parameters. So the source and destination ones, those are automatically published. When you use an all, when you use a merge, it also publishes the feature types to read. It doesn't do that if you've made the edit afterwards to merge the feature types, but if you selected that while adding the reader, it automatically publishes the feature types to read. And that's good, we actually want that. So we don't need the source data set. That's never going to change. We don't want the end user to be prompted for that, so we'll delete that. This does not delete the parameter itself, it simply unpublishes it. Now the output format is currently ESRI shapefile. If I double click on it, we can see that we get the full list of formats. Any format someone wanted, they could choose, all several hundred of them. That might be excessive. So that's unkind to the end user to expose so many formats that they don't really need to take a look at. So let's create a new parameter that we'll use instead, and it will have a limited number of formats available. Let's right-click on Publish Parameters. So we're in the navigator, User Parameters. I right-click on Publish Parameters, and I have an option to create a user parameter. Now, the reason why I'm doing this right now is that quite often these parameters which are created, if I edit the definition, I can't change the type. I'm not entirely sure why, but quite often with the automatically generated user parameters, I cannot change what type of parameter this is. So I'm gonna have to create an entirely new parameter to be able to choose my type. So I'm gonna create a user parameter. So now you can see I can change the type, and the type is going to be my favorite type, choice with alias. I find that generally if I'm using published parameters, it ends up being a choice with alias. The name of this is going to be output format. This name is the internal name of it, what you see here. The end user will probably never see this. It is published. It is not optional. You have to set this guy. The prompt, this is what the end user will see. Select output format. Keep in mind this is what the end user will be seeing. So you might want to phrase it in a way which they'll understand. File type, probably shapefile. Try to be helpful. Configuration. Let's configure this. Let's click on the three-dot button. And what it brings up is this. The display name is what the end user sees. The value is what we hand to FME. So if we're looking for formats, what we're looking for are the short names. People aren't going to know the short names off the top of their head. Even I would not be able to tell you most of the short names without consulting the documentation. So typing in those short names is not something which I really want to do. But what we can do is import them. I can import it from a data set, coordinate systems. So we can also use this while setting coordinate systems. Reader formats, writer formats. We are going to be writing out, so I'm going to import it from the writer formats. So it brings up this dialog. So I'm importing it from the writer formats, and now it gets super easy. So let's see, the formats I want are ESRI shapefile. So I do shapefile. If I type in the bottom here, notice it starts filtering, and I can check the one which I want. Then type in the next thing to search, DWG. A lot of DWGs, let's go with that one there. GML. There we are, about midfield. Map info tab. Let's go with the My tab one. So now I've got about 4 different coordinate systems selected. Ultimately, if you're a little lost here, just get ESRI shapefile in there and then just choose a couple at random. So now I can see it's given me the display name and the values. These are the short names. And you can edit these. And you can move them up and down the list as well. You can even supply a default value if you so like. Okay, so now when I run this translation, I can see that I have my select output file type, probably shapefile, get this one, and I can choose whatever I want. But right now, this is like the door close button in an elevator. It's there, you can click it. It's not actually hooked up to anything. So now we need to hook that up to something. So let's go back to the navigator. We have this one here, format generic. That's the previous one. Let's delete that. And now we want to connect this to something. So let's right click on that, and we want to apply this to. So we right click on our output format, apply to. There's a bunch of things here. But if we look for generic, there's only a few generic options. Base file name, coordinate system, destination, generic, any format. So that's the output folder, MIME type, output format. So we can select the output format. The other option is to go to the reader itself parameters, find that particular parameter, right-click on it, link to a user parameter, and then choose output format. So you can do it either from the published parameter or from the parameter you want to link to the published parameter. So now when I run this, I can choose, say, a feature type to read. I want my parks. I want to write it out to ESRI shapefile. I run the translation. And if I open up the containing folder, there we are. These are my park features. Notice they're all called new feature types. New feature types point. Could do better there. So let's use a fan out. If I examine the features that are coming out, click on one of these guys here and go to the information. This is kind of all cramped in because I'm using a very small screen. But I have a number of attributes here. And one of them is FME feature type. The FME feature type format attribute always contains the name of the feature type this feature came from, even when you're merging. This is never going to say all. This has the original one, in this case, parks. So on my output here, I could fan out on that FME feature type. Let's see, is it showing up? For a while there, I might be going blind. I don't actually see FME feature type. That's okay. Let's go to the text editor, see if we can find it there. Our FME feature attributes, oh, there it is, FME feature type, between description and water fountain. I wonder if I was just missing it before. Oh, I was, description and water fountain. Okay, so we have our FME feature type. Most of the format attributes are not exposed by default. You may have to go through with an attribute exposer transformer in order to see them. But FME feature type is so useful that in most transformers, we do automatically expose that particular format attribute. So now we're going to fan out by the name of the original feature type. Hit OK. Let's run that translation again. And there we are. Now we have a parks underscore point. Because we used FME any, it's assuming that it could end up with any combination of geometries. So it's always going to be adding in that geometry suffix. There are ways around that, and we'll talk about those later on. Okay, now for writing this out, let's try running this again. We have our output format here. Training, let's do /community mapping.zip. Just by specifying the .zip file, FME will know to make sense of that. So if I do community mapping.zip and then run this again, go back to the folder, now I have my community mapping.zip with my parks inside of it. Now, in examining that data set, I actually view the written data. This is a shapefile. One of the things you'll notice in the table view here is that I have all of the attributes which are defined because I copied it from over here. So this is a culmination of all of the attributes in all of the tables in this FileGeo database, and they are defined on the output. So they're all going to be there, whether I want them to or not. There is a way to fix that by using something called a dynamic translation. So this Fanout, this is the simple way of getting separate outputs based on an attribute type, separate output feature types in this case. But this really only works well if all of those output feature types have the same schema. If they have different schemas, you'll want to use a dynamic translation. So dynamic translations are a way of handling the source and destination schemas automatically. No longer using a static schema definition, using a dynamic schema definition. So dynamic translations are, I guess, schema-less workspaces. They care a lot less about the schema, but they're trying to handle it automatically. Dynamic means that the source and destination feature types are not locked to a specific schema in the workspace. Everything we've done so far in the basic and advanced training, we've always had a schema defined in our workspace. For example, layer called X with this list of attributes of certain types, numbers, strings, and so on. So now we're going to create a translation which isn't locked to a specific schema. We don't necessarily know what layers or attributes we will be working with in advance. Whatever comes in, we'll have FME read it, and whatever goes out, we'll write it out. Common uses for dynamic workflows include applying a simple data transformation to all data regardless of schema, such as clipping, coordinate system transformation, etc. When the source schema is not predictable or well-defined, ad hoc data transformations, when the destination format might vary, or when long-term maintenance of the workspace is required. For example, if the new feature types or attributes are added to the source data, the workspace would not need to be changed. Dynamic readers basically means you simply have the merge parameters turned on. So we have the feature type merge. The only thing you need to do to make this dynamic is just turn on the merge feature types. Data will be read in regardless of attributes or geometry type. Remember when we used merge feature types when creating a reader, we had this automatically called all. That's a dynamic feature type. Dynamic writers are a bit more complex. We're not just going to set one thing to make it dynamic. As though all attributes and geometries are written, more awareness of what is to be written is needed. By default, dynamic writers will respect the schema from the reader. They will take the schema from the source data and then use it for the output. Dynamic writers can also derive the schema from a user-provided resource, including datasets, databases, and lookup tables. So you're not locked in to just what you have already existing on your source. We can read in the source dynamically, do a fair bit of transformation of the data, and then obtain our dynamic output schema from somewhere else entirely. There's a little grid down here about when you would want to use these various options: static, Fanouts, dynamic, generic. So if we know the feature types and I know the format, stick with static. That's what we've been doing so far for most of the course. If you don't know the format, generic and static, and then you can see it goes from there. So if you're not sure if you want dynamic or generic or fanouts, just consult this chart here to figure out what kind of translation you should put together. Okay, another pop quiz. So we pick out everything we think is true. A dynamic workspace will read-write any format of data. The dynamic workspace, that's really just talking about these feature types. It's the generic reader or writer that will actually work with the different formats of data. So I'm going to say that is not true. A dynamic workspace will read-write any feature types in the source data. I'm going to say that's true. That's the entire purpose of it. A dynamic workspace will read-write any attributes in the source data. That is also true. A dynamic workspace will read-write any geometry in the source data. That is also true. Let's see if I'm right. Woohoo! So, creating a dynamic translation. Once you've already created your workspace, you can convert it over to a dynamic translation. For the reader parameter, it's just turning on the merge feature type. That's it, you're done. On the destination feature type, we've got this whole dynamic schema definition. You just turn that on, and then there's things here that you'll have to change as well. That'll go over to dynamic. If you're generating the workspace, you can choose this dynamic schema that sets the reader to merge and the writer to dynamic. If you're just adding the reader, remember we have the individual feature types or single merged feature type. Just choose the single merge feature type and that automatically turns on that merge. And then you have your dynamic reader. When you're adding the writer, in the drop-down you choose Dynamic Advanced and that'll set it as being dynamic. So it'll end up looking like this. We have all writer feature types and it'll say dynamic. When you just do the fan out, it looks like this. It looks like what you're fanning out on. The dynamic will say dynamic because there's more things set. So let's create a dynamic workspace. Now this has us actually start the workspace and it looks like it's the same thing. We've gone to the effort of creating that publish parameter. I'm pretty sure we can just continue adjusting the workspace we currently have. So instead of creating a new workspace, let's try the following. Let's take the workspace that we already have, open this up, and set to dynamic. If I created this dynamically, it does actually default to FME feature type. So you can see when I hit OK, now it says dynamic. The default for the dynamic is to use FME feature type, but you are not locked into that. There are other options. So let's run this workspace again. And I'm going to inspect my output. So again, because it's a generic writer, it doesn't know that I wrote this out to ESRI shapefile. And I'm reading a zip file. I doubt it would figure out that it's a shapefile. Let's see if it does. Nope. Okay, so let's actually open that up as a zip file reader. Actually, let's see parameters. ESRI shapefile. Let's see if that kicks it loose. Oh, it does. I've still got all of those attributes. Now, I think if you had actually created this using the generate, there wouldn't be any attributes here. For me, because I started off with a normal translation, I do have all these attributes. So let's do a little bit of cleanup here. Let's go to our user attributes and let's delete everything. Because anything which you do define here will be added in addition to what you already have. So I'm going to delete all of it. So let's open up this feature type, go to user attributes, dynamic, delete it all. And now let's run that again. So let's delete all those attributes. Run the translation again. Let's try inspecting it this time. Set the parameters, shapefile. And okay, let's see what I get. Ah, there we are. Notice that I only have these 4 defined attributes: park name, park address, park URL, and object ID. Those aren't what's listed here. These are the attributes that were in the source file geodatabase. So now we're dynamically handling those attributes. If I wanted to write something else, let's do a prompt and run. I have our destination generic, ESRI shapefile. I seem to have lost my feature types to read. Well, let's see where that went. Feature types to read, parks. Oh, that's weird. Am I not seeing it? Oh, my features to read ended up unpublished. Oh no, there it is. Feature types to read. Oh, that's weird. I could have swore that that was in there. Well, I can go in and change it there. Feature types to read. I want parks and food vendors and libraries. Okay. Run all of those. And now when I go to my output, community mapping, now I have my libraries, my parks, my food vendors. You'll notice something here. I no longer have that underscore geometry type. The fanout isn't smart enough to deal with different geometries based on the schema, but the dynamic translation is. It's smart enough to check with the source schema, see what the allowed geometries are, and then do the translation based on that. We'll see those settings in just a moment. Let's take a look at schema handling in dynamic translations. We've turned on the dynamic schema, but we haven't really talked too much about the dynamic schema handling and what exactly it's doing. There are many places that the schema can come from. We'll now look at some different methods for creating the dynamic workflows. Schema handling on the reader side is fairly straightforward. It really just does consist of this merge feature types. So we've got the merge feature types, turn that on, and that's about it. At that point, the users that we have here, if I were to actually just bring in a single feature type, that would be sufficient because it doesn't actually matter what's listed here. We don't have to have a comprehensive list of everything. Just to prove that point, I'm actually going to, do I delete this? I can update the feature type definition. I think that's what I'll try doing. So I'll go to the navigator, my reader here. Maybe I'll do it from the readers. Update feature types. So I'm going to update this particular feature type. For the parameters, I'm just going to choose one of them, food vendors. Hit OK. All. So now I just have my food vendors. But if I run this translation, again, I'm not entirely sure why I don't get my publish parameter there for what I'm actually doing. So, well, I'll just run it. That's actually reading in more than just the food vendors. If I open this up in my community map, I can see I have my food vendors and my libraries and my parks. Just going to grab my parks shapefile there. Actually, if I bring this over to visual preview, parks shape, that might work. Let's just do the whole zip file. There. So I'll tell it to read in all the ESRI shapefiles, hit OK. Oh, someone asked, did my private parameter get moved to, or did my published parameter get moved to private? That's entirely possible. I'll double check on that in just a second. Okay, so I have my food vendors, libraries, and parks. If I just take a look at my parks, I can see that even though I only have defined on reading vendor ID, vendor name, vendor description, I still ended up with my park name, park address, park URL. So with a with a dynamic reading, it doesn't actually matter what's defined here. It's going to read them all in regardless. Let's double check on that. See if it moved over to private. And I'm betting that's what it is. Oh, no. It's not there either. And a definition. Text list. Oh, but that brought it back once I went in there. Ended up in a weird state somehow. Okay. Okay, moving along. So for the reader, it's just a merge. For the writer, there's more things to consider. In the writer here, once we've turned on the dynamic schema definition, we have our schema sources. Well, first of all, the feature type. It's going to fan out by default on the FME feature type. You just have to remember you're not limited to that because sometimes you'll want to actually grab your output feature type names from somewhere else. The geometry that is from the schema definition. It's going to look at that source, decide what it is, and then go from there. That's working well for this translation because we're reading in from a file geodatabase and writing out to an ESRI shapefile. And both of those only allow a single geometry type per feature type. So that meshes well. It might not always do it, so you can choose first feature defines the geometry type as well. For this particular translation, either of those would work. But if I had a source data set that had multiple geometries per feature type, I may have to get a bit creative. This would work, but there's other things that I might have to do instead. FME any is another way of doing it, and it'll simply append on what it is. So the first feature defines, it would mean that if a polygon gets there first, it's a polygon output feature type, but it's not going to label it as such. It's not going to add that suffix. If I do FME any, then any geometry that gets there will be allowed, and it'll just add that suffix. With the other option, with the first, I believe that if another one shows up with the wrong geometry type, then it's not actually going to write out, and you'll get a warning message. Dynamic schema definition. Here are our schema sources. There's multiple locations that we can actually get the schema source. So we have a schema from a schema feature. That's set by default. It's expecting a feature that will actually contain the schema. We don't actually have that feature in this situation. That one's not coming through. But we also have the source data set as well. So in this case, it's actually going from either schema from schema feature or from the source data set itself. We'll talk more about these schema features later. Some other things that we see: schema definition name, default feature type name above. So right now, when we write out to this feature type, that's also where it's grabbing the schema. We could grab it from somewhere else entirely. And also we have the attributes to remove. By default, because we're copying over all of the attributes, maybe you don't want all of them. Maybe there's some private information in there. So you can actually select which ones you want to remove globally as well. So a schema consists of the feature type, attributes, and geometry. With dynamic feature types, we have control over how these are set. The feature type name is usually directly specified, but we can use the FME feature type format attribute to copy the value of the name from the source feature type. We could also use the value of some other attribute entirely. For example, here, perhaps the actual output feature type name we want is different. So what we would choose instead is the neighborhood name. Now here we have the schema definition name. We could actually still grab that from FME feature type. So this is referring to what's on the source. Or again, we could refer to something else entirely. So far that just sounds like a complex feature type fanout, but dynamic feature types do not have a fixed schema when it comes to the attribute names, values, or geometry. So in addition to being able to just, basically fan out on that feature type, the schema is also handling our attribute definitions. And it's a bit smarter about the geometry. A little bit more about the schema sources. When creating a dynamic workflow, the destination feature types must know how to obtain the desired output schema. In the writer feature type, there is a parameter for the schema source. The output schema definitions have to be obtained from somewhere. It does not have to be from our source reader. We can choose some other source data set or use a schema feature. The source of the schema could come from the source data set. That's what we've seen so far. It's a dynamic translation default. It could come from an external data set using Workspace resources, used when the desired schema is different from the source schema. So if I've added something like a resource, and I think I had that in this workspace, or was it the previous workspace? The workspace resources here, I could read in the schema definitions using that workspace resource and then refer to that. The source schema could also be coming from a table in a database. This is useful when the destination feature type will be stored in a database with a fixed schema. So I could just check what's currently in the database, use that. So we could grab it from a resource, could grab it from a database. It could be in a lookup table. That's useful when maintaining a schema outside of the FME environment. So I could have some entirely separate lookup table, which I can maintain external to FME, and then FME makes use of that. It could use a feature in FME called a schema feature. This has a list attribute to provide a destination schema for defining the destination schema dynamically within the workspace. Or it can be derived from multiple sources, useful when needing to combine multiple source data sets of unknown schema or add unknown attributes to a static schema. We don't need an entire source data set to retrieve the schema. Instead, we can use a workspace resource. This is also what we use to retrieve parameters for the generic reader. Any reader data set in any format can be used as the source for the destination schema by adding it as a resource reader. A resource reader is a reader that returns the schema of a data set, but no actual data, no features. It is possible to add one, as we did before, through readers, add reader, resource, or just right-click on the workspace resources and you can add a resource there. The external schema allows you to provide a fixed standard. Basically, it acts like a template for your output. And it is useful when the destination feature type will be stored in a database with a fixed schema or when maintaining a schema outside of the FME environment. Sometimes once your workspace is created, you don't really want to go back into Workbench, or it'll be maintained by people who are unfamiliar with Workbench, but are familiar with, say, editing a spreadsheet. They could manage large portions of the workspace or large portions of the translation simply by managing that spreadsheet. The dynamic properties allow you to configure what schema you want to use. First, we'll look at attributes. It's possible to change the attributes that are written in a dynamic translation. Under the dynamic properties, the source schema defines the source schema for dynamic writing. So this bit here. So where is it going to get the source schema from? However, there is another parameter, schema definition name, which will override the attribute definitions. So this is where, from this, it'll actually get the schema definition. Here, for example, we have a dynamic translation. The output feature type name will be the value of neighborhood name. The schema source is Park Schemas it's a Park Schemas Excel spreadsheet. And in the park schemas, we can actually look for a particular sheet. You can add new attributes to the output schema. This is done in the normal way under user attributes. So even once I've set this to dynamic, I might be creating additional attributes during the translation. I could drop in an area calculator, calculate areas, and add a dynamic attribute, park area. This will be added to all of my outputs. Deleting an attribute is done under the attributes to remove setting. So again, if I want to delete an attribute, I can't delete it from here because this doesn't actually matter if they're there or not. Under parameters, we have the attributes to remove. This can be handy if you want to get rid of things like object ID. Remember when I was inspecting my data before, I did have that object ID because that is an attribute in File Geodatabase. If I want to get rid of object ID, I can specify that here. Object ID. And then that won't be written out. So we've looked at the feature types, the attributes. Now we need to consider the geometry. The allowed geometry can be set to a specific geometry if you know absolutely everything in your sources will be the same geometry. It's not particularly likely, but I suppose it's possible. The other option is to grab it from the schema definition itself. Some formats do not allow a mix of geometry per feature or only allow certain geometries to be written. In those cases, it's necessary to define the destination geometry definition. So we can have a fixed geometry. That was the first option we look at. The other option is the first feature geometry definition. So the geometry for the feature types can be defined by the first feature the writer feature type receives. First past the post. This means that when you're not sure what geometry you may be handling or whether they will match the writer feature type schema, you can choose the first feature defines geometry type option. This way, the author doesn't need to be aware of the geometry type before running the translation. So again, a little matrix to consider on whether or not you actually want to use dynamic. I'd only use dynamic if you absolutely have to. Just like the fanouts or the generic readers and writers, this can be a little tricky to debug. If you can get away with using static schemas, static definitions, I would certainly stick to those. But if you don't know the feature types, and I don't know the format, that would be a generic and dynamic, which is what we have right here. Okay, so let's continue on. So the previous exercises, we were translating the community mapping data set. This data set's become out of date. The planning department therefore wants to start building a new community mapping data set. The data set will have some new data, but use the existing schema where possible. They also, in order to use an open standard, want a format change to GML. At the moment, we have two data sources which have been identified as being required in the new community mapping database. They are fire halls in a GML file and city parks in a map info tab file. There was already parks data in the community mapping, but this new data set consists of polygon geometry, not point geometry. You may have noticed earlier when I was writing out to parks, it was parks_points when using a feature type fanout. The parks data set in the file geodatabase is a point feature class. We now have a map info tab with a map info tab file with parks data as polygons. We want to use that instead. The fire halls data is entirely new data. So we're actually going to start an entirely new workspace here. So let's go to Start New. We'll start with the blank workspace. Let's generate the workspace, Control G. So Control G will bring up the Generate Workspace dialog. That way we don't have to go in and edit our feature types after the fact. We can just choose Dynamic Schema right off the beginning here. We're going to read in. We have the parks data, but we'll add that later. We'll start off by reading in the GML data. The GML data of our fire halls. So the fire halls data is in FME Data 2019 data, emergency, and we have our fire halls.gml file. We'll open that up. We'll be writing out to GML as well. GML, writer data set will be FME Data 2019 output training new community map.gml. So backslash FME Data 2019 backslash output backslash training backslash new community map.gml. And we'll use the dynamic schema. So let's generate that workspace. So now we have our all, and over here we have dynamic. Right now it's just reading in one feature type, one data set, the fire halls. So I mean, that's not very impressive that it's able to do that. Just keep in mind that there's no attributes. Well, actually we get the GML attributes, those show up no matter what. But nothing's defined on the output here. But we also know that as long as we're reading in additional GML files, they could all be handled through this. Let's save our workspace. This will be exercise, where are we at here? 4. 3.4. Now we also know that we have an additional data set, map info tab file with parks. So let's add a reader. So let's click on the canvas, type in my tab. We want the map info tab, my tab reader. So I'll hit enter there. The data set, FME Data 2019 data parks, parks.tab. Excellent. Backslash FME Data 2019 backslash data backslash parks, and in the parks folder we have our parks tab file. We will also bring this in as a single merged feature type. and we'll hit OK. So why would it be important to do these as, if I'm reading in two separate data sets, why would it be important to bring them in as these generic schema or dynamic schema feature types? The reason is if the attributes that are in the data sets actually change over time, this would automatically handle that. So if from year to year there are additional attributes added or attributes removed, using these dynamic readers, the dynamic schemas for the readers would handle those changes in attributes. Let's expand this. Might as well cache this up while we're waiting. Okay. Now, a little bit of best practices. I have our reader feature types, all and all. This is terrible for best practices. What on earth are these? Anytime you're looking at your workspace, if it's not immediately apparent what these things are, add a comment. Control K for comment. It suggests the reader and format, or sorry, the feature type. Actually, I think that's probably the data set. And format, that's good enough. So just Control K, sticking with the defaults. That gives us enough information. Now we know these are fire halls and parks. Now, the output schema that we want is not the schema that we have on our fire halls or our parks. We want to write out our parks here, which have this schema, but we want to use the schema from our file geodatabase. So these are the entirely wrong schemas. Let's hook this up. So we want to grab the schema from the file geodatabase. So in the navigator, find your navigator. We have our workspace resources. You can right click and we're going to add a reader as a resource. You can also do that through the menus at the top, choosing reader, add reader resource. So let's click add reader resource. Our source format. If you type in open API, there's only one format with an open API. ESRI geodatabase. Choose our community map.gdb file. For the parameters, make sure it's remembering last time I had selected food vendors. This is why it's always really important to double check these parameters. Otherwise, it would only be bringing in the schema from food vendors. Let's delete that. So now it'll read in all of them. So parameters, table list, make sure that's empty and hit OK. So now I can get the schemas of all of the feature classes defined in that file geodatabase. Now for our output, by default, it's going to be grabbing the schema sources. Right now, it's only looking at fire halls. If I run this translation as is, I would not be getting the appropriate definition for my parks. It would not be looking back here at my parks and grabbing the correct one. It would only look to my defined fire halls. So now I want to go into the schema sources and choose the community map. My park reader has the entirely wrong schema. I don't want to use that schema at all, so that's why I ignore it. Fire halls, I can't uncheck that because community map doesn't have fire halls defined, so I need that. Hit OK, there we go. Let's run the workspace, see what we get. So this is all going to go out to community map GML. And when I inspect my community map GML, I should end up with my fire halls and my parks. With my fire halls, I have the same schema as my source schema for the fire halls. And for my parks, I have park name, park address, park URL, an object ID, which is what the source schema was in my file geodatabase. It did not grab things like dog park, washrooms, etc. So I'm writing this out using the schema from the file geodatabase. There are some attributes here that we don't need. Object ID. That's going to be defined in both of them. Actually, it's only defined in the parks here. The fire halls GML, when I look at that one, that is defined from the GML file. I don't have that coming across. But parks, it's coming from a file geodatabase. That will give me my object ID. I'll want to get rid of that. So in my destination here, attributes to remove, we will remove object ID. Hit OK. We can run all this again. Inspect it. And now for my parks, I no longer have that object ID. So it's gone. Now, one of the attributes that I'll want to add, let's just say for proper maintenance, is last updated by. I want that to show up in all tables. So the name of this attribute, which I'm going to add to all outputs, last updated by. Character, it doesn't have to be 20 long, it's just going to be a name. Assuming nobody has a crazy long name, we'll go with 30. We could even give it a value. Me. Now when I run this again, and inspect it, the fire halls has last updated by me, and the parks has last updated by me. Okay. So there we found where I can get my schema from some entirely different data set. I'm using another data set entirely, the file geodatabase, as a template for my parks GML file, writing out to a community map GML file. Now there are some other things that we could do. Let's say I wanted to add some attributes here, but I only want it for one stream. I want my parks to have an added attribute, but not my fire halls. Well, how could I do that sort of thing? Well, I could define the schemas somewhere else entirely. So it's not actually my file geodatabase, it's not my source data set. I have some other data set entirely, and there I can maintain it. I can add and subtract ones just through basically a table. So here, this is an Excel spreadsheet. You can imagine this could also be a CSV file. We can then read that table as a resource. So you notice that what it has here, the feature types. Feature type fire halls. Notice that this is duplicated many times because this is all about fire halls, fire halls, fire halls. Attribute name. These are the different attribute names. I have to give each one of those attribute names a attribute type. Here I can specify the attribute types. And then a geometry type. You only have to specify that on the first one. This will be FME points. It just assumes the same for all the rest of it. and then I can order my attributes as well, 1, 2, 3, 4, 5. So I have that kind of control over the attributes for this particular schema. So then I can add this as a reader resource schema from table, choose that Excel spreadsheet, and then I can choose that as my schema from table, as my schema source. So that way I can manage that externally to FME. Anyone who has access to that CSV file, or that could even be a database table somewhere out on the network, or a spreadsheet. Probably a Google Sheet would work just as well. I can also construct it on the fly within the translation itself. So the schema can be defined using a list attribute, which can be created in an attribute creator or an attribute manager. So I just create this attribute, and this is a list. And I have an FME data type and a name, and I just construct it just as I would with that table. That feature then becomes a schema feature. There's a number of things that you have to set on it. You have to let FME know that this is a schema feature, and then I can make use of this schema feature and manage that within the translation itself. So schema from schema feature. Now, one of the things that you notice is that you have to set the data type. Finding documentation for that can be tricky, so here it is. We have character fields. These are your options. Keep in mind that these are all using FME underscore something. FME will then, depending on your writer, cast it to an appropriate feature type when writing. So you don't have to set, say, a map info underscore varchar or something like that. FME field types will handle that automatically. So we have character fields, integer fields, numeric fields, date time fields, and other fields as well. Okay. Pop quiz. The ability to construct a dynamic schema from attributes in a workspace has a lot of possibilities. Yeah, no kidding. In fact, one of these FME transformers automatically creates dynamic schema attributes, specifically so you can create a new schema. Which one is it? Well, we said schema a lot there, so my gut feeling is going to be schema mapper. Let's see, what else we got here? Attribute pivoter. I have no idea what that does. I'm guessing it pivots things, maybe pivot tables. So I'm going to say it's not that one. Python caller, certainly not that. Executes a Python script. Clipper, no chance. Let's check that. Oh, no, is it the attribute pivoter? It is. You see, I've never actually done that. The attribute pivoter. Oh, I'm going to have to bring that up here. Ah, I see. So it takes what you have and creates the attributes that you need. The schema mapper would then actually make use of something like that. No, wait, you don't even have to do that. Nope, that would just allow you to make use of a schema feature. Okay, exercise 5. This is our final exercise of the day. Well, let's begin. So we have a starting workspace. I think we're actually just continuing from our existing workspace. I don't think I've broken anything too much in here. So at this point in time, we have two tables. We have our fire halls and our parks. But now another one's required, and the planning department wants you to update the workspace. So rather than having to make changes each and every time they add more data sets, we want to simply create an Excel spreadsheet that contains the schema definition. That way the planning team can edit the schema definitions themselves, and then they don't have to bug us for the future updates. So they have an Excel spreadsheet. See FME Data 2019 Resources Desktop Advanced Community Map Schema.xlsx. We won't bother opening that up at the moment just yet because it looks like this. We have our feature type: fire halls, parks, zones. Fire halls, parks right now we're grabbing from the file geodatabase. It looks like we'll be getting rid of that resource. We'll be using this resource instead for our parks. And then obviously they're planning ahead for when we're going to need to read in zones. So let's start updating our existing workspace. Okay, so we're going to delete the community map resource reader. We have our workspace resources. We have our community map resource here. We don't actually need that anymore because we're going to be using our upcoming table. So we'll delete that. What we are going to need is a resource that points to that Excel spreadsheet. Now we're not going to read it in as an Excel spreadsheet because we specifically want to grab the schema from it. So this will interpret it correctly. So right click on your workspace resources or go up to readers, add resource. Add reader as a resource. The format is actually going to be schema from table. So we're going to grab schema from table. And now we're going to point to that spreadsheet, which is in /FME Data 2019 /resources /Desktop Advanced. And we have our community map schema. So we're going to grab our community map schema and open. Let's double check the parameters. Under the parameters, it'll ask us which format we're going to use, which reader we're going to use to read in this schema. There's a number of options here. You see, you can actually read it in as pretty much any format. We're going to read it as an Excel reader. That's correct. Parameters, make sure it's actually reading this in correctly. We've got two sheets here, actually. What's on the second sheet? There's nothing on the second sheet. Let's not read that in. Here's the first sheet. We can see that we have a feature type, and the feature types, attribute names, all the attribute names, attribute types, geometry type, and the attribute order. So that's all configured correctly. We want to select the sheet that contains it, sheet 1. Now we need to do a bit of mapping. This is why we just don't read it in as an Excel spreadsheet, because we need to map what's in here to what FME is expecting. Now, in our spreadsheet, we named everything pretty appropriately: feature type, attribute name, attribute data type, geometry type, and attribute order. But you might not always name it like that. So we need to match it up down here. What is the actual feature type column? It is feature type. The attribute name is attribute name, attribute data type, geometry type, attribute sequence, attribute order, multi-value separator. I think that's correct. So get all of that configured. I'll give everyone a moment. and OK. No coordinate system, of course. Hit OK. And now on our output for our schema sources, we don't want to use the fire halls. We don't want to use parks. We want to use the community map schema. So use the community map schema from table. So now we've got our schema for our parks, for our fire halls. We noticed that there was a zones in there. We might as well add a reader for our zones. It's also a map info tab file. We could add a separate reader for this. I think we could get away just by, just thinking about what the easiest way to do is. What could work either way is just adding it to the fire halls. I think that would work just as well. Here, to keep things simple, we just added another map info tab reader and selected zones. But I think if we go up to our fire halls here and edit this, this should also work. So if we edit fire halls GML, notice we got these here. So hit that. This is reading from fire halls GML. If we click this down arrow and select multiple files and folders and go find that grid GML, or sorry, that zones, sorry, not grid, that zones my tab file, I think it'll work just as well. So let's add files. So you have to make sure that you choose the multiple file selector because they're not in the same folder. So we're going to add files. And FME Data 2019, data, I'm going to guess it's in zoning. Oh, am I choosing the GML? Oh, Mark just pointed out that I'm in the GML reader right now. That's the wrong reader. Sorry, cancel out of all that, cancel out. It's the My Tab reader. It's a My Tab format. So let's do this again from the My Tab reader for parks. Let's open that up. Nope, not inspecting. Opening up the parameters. So the parameters here, right now it's map info. Sorry, I'm at map info tab. Okay, so I'm in the right one here. Parks.tab. Let's select multiple files and folders. And we will add a file. And it is in FME Data 2019 data zoning. So that's FME Data 2019 data zoning. We have the zones one. I eventually would have figured that out when I went into zonings because it would be looking for GML files and wouldn't actually show me anything. Okay, so now we have our zones. So this is different from what we have in the manual here. We're just going to read both of those in through our fire halls. Might want to, sorry, not fire halls, again, parks. So this is parks and zones. That should work. Let's see what happens here. There, so I have all my parks, all my zones. When I inspect this output, I have got my fire halls, my parks, and my zones. The zones, all the attributes are defined in my spreadsheet, and I can see there they are right there. Zone name, zone category, and what I've added, last updated by me. Okay, so we've got about 10 minutes left. Let's see, can we update the spreadsheet? Let's find out. So the spreadsheet itself is kept in FME Data 2019 resources, FME Desktop Advanced, Desktop Advanced. There's our community map schema. Well, let's see what happens when we double click on this. I did install OpenOffice. This should allow us to edit this. Cross your fingers. I've never done this part before. I don't want to register. Let's just finish. Oh, seems happy with that. Okay, there we go. So we can see our feature type: fire halls, parks, zones. So what is it that they wanted us to change? So we have changing the feature types. That would be tricky. There are ways to do that, but doing it right here, like this is kind of what everything else refers to. So we'd have to have some other additional lookup. It is doable, but non-trivial. Changing the attribute names, that is a little bit easier. We'll have to also edit some stuff in the workspace to make sure that that actually works properly, because right now it's looking for hall number. If I change that to something else, there are additional steps required. So it wants us to change name here to hall name, address to hall address, and phone number to hall phone. So let's change name to hall name, address to hall address, and phone number to hall phone. You can save that. And we'll save that back out to Microsoft Excel. Oh, we got to be careful here. We don't want to create a new file. Let's try that. Excel SX. .xlsx. I'm hoping that doesn't destroy my file here. Let's see, is there any other Microsoft Excel options there? Nope. Let's see what happens here. Yes. Keep current format. I don't know if this is going to work. Our adventure may end here. So I've changed that. See what happens when I run this translation. Okay, well, it ran. Let's see what happens when we inspect that. So I got my fire halls. There we are. Hall name, hall address, hall phone. Notice that I no longer have any values for those, because I still have to have those defined somewhere. So there's no values for the fire hall table, because as FME has no way to know that that mapping has happened. So let's make a little bit more use of what we have in that sheet. Okay, so let's go back here. We have our sheet 2. We're not going to be using this in the dynamic schema settings. We're going to be making use of this Excel spreadsheet in 2 places now. There is a transformer called the schema mapper, which can be used to map schemas based on what it finds in a spreadsheet, like this spreadsheet. We're going to create 2 new attributes: old attribute, old attribute name. Let's see if I can resize that. And new at name. Make sure you spell it consistently. If you misspell it, just make sure you spell it in a way that you can come back to it later on. Okay, so I have old attribute name, new attribute name. The old attribute name, which I had before, was name. That's what's in the actual data. I had name, I had address, and I had phone number. I want to map those to hall name, hall address, and hall phone. So I put those in there, and now I'll save that. Control S. Might want to give this sheet a better name, but for now, sheet 2 will suffice. So I now have this in my spreadsheet saying the old attribute names are these, new attribute names are these. Now I need to make use of those. So I've saved this. File save. Yep, already done that. Now I need to run all of those through a schema mapper. Now, I need all of that to go into the schema mapper. If I click on this port here, when I drop in the transformer, it should drop it in to both of those connectors. So type in schema to bring in the schema mapper. Drop it in. Notice that both of those are now connected up, and they go into the schema mapper. Now to make use of the schema mapper. Now the schema mapper can do a lot of things. This transformer always worries me anytime I have to demonstrate it because there's just so many things that it can do. We need to read in that spreadsheet. So we're going to read in the Excel spreadsheet. I need to select it. This is our /FME Data 2019 /resources. It's in the resources Desktop Advanced. So it's in the Desktop Advanced, and it's our community map schema. Now you got to check the parameters. We're only interested in one of the sheets. That's sheet 2. That looks like this. So make sure you're reading in that particular sheet. When you're reading that in, hit next. And then there's a bunch of different things that we can do. We can filter features. We can map feature type names. Remember before I said we can't just change the feature type name, but here I could start mapping feature type names to some other feature type name if I had an Excel spreadsheet to do so. Map attribute names or create entirely new attributes. Let's attribute map. What the original one was the old attribute name. The new one is the new attribute name. I could give it default values if something doesn't exist. And then I can either keep or remove the ones which are there. I no longer need the old attribute names, so I can just remove them. Hit OK, hit finish, cross your fingers and run. And now when we inspect this output, I have my fire halls, and whereas before it wasn't mapping my hall name, hall address, or hall phone number correctly, now it is. So now when someone wants to manage what these things are called, they can do it through here. So maybe I decide, oh, you know what, calling those halls, that's name, that's better. Hall address should be street address. Hall phone number should just be called number or contact number. I can just change that there. For that mapping, and then here, change what they actually are called. Number, not sure if I got that right. Yeah, street name, street address. I think I missed something there. I think that was always hall name. So now when I save all of this and run it, so now when I inspect that, my fire halls should be using my new mapping. I messed up number there. I think I just didn't grab it from the original name there properly, but you get the general idea. So now whenever I need to do that sort of management, I don't have to go into Workbench to do it. I can just lay down some ground rules for someone else to edit it directly from here. Okay. So that's it for today.